Okay, let's look at section 5.6, using the Pythagorean theorem. Today you may need your calculator and your highlighter as well as a pencil or pen to take your notes. So if you need to take just a second and get that, you can pause the video and get those materials and then come back for the lesson. Our essential question for this section is, how do you solve a right triangle? Key concept: solving a right triangle. To solve a right triangle, the Pythagorean theorem can be used to solve a variety of problems. It is helpful to use a diagram to determine what part of the right triangle is unknown. On the ISAT and on other tests that you're going to take in the future, as well as in this classroom, you're going to see lots of problems that can use the Pythagorean theorem to solve them. And so you need to become familiar with those types of problems, and you need to understand that anytime you see something that might have a right triangle, you should at least consider using the Pythagorean theorem to solve that problem first, because that's something that would come up with a right triangle. One thing that you definitely need to do is draw yourself a diagram. So if there's no diagram drawn, you should always draw one for yourself to help you to see what the problem is and what it's asking. Let's look at an example. It says, write an equation that can be used to find the length of the ladder, then solve, round to the nearest tenth. Here they've given us a diagram, and there's a building that's 18 feet tall, and there's a ladder that's placed 8.75 feet away from the building, and then it wants to know how tall is the ladder. So here to here, how tall is this ladder? It says, notice that the distance from the building itself and the ladder form a right triangle. So here, the distance of the ladder from the building and the building form a right triangle. So we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. Notice that we have a and b given to us, and we're looking for c. So if you need to look back at section 5.5 on how to work problems given a and b and finding c, you can do that now before you get started on this lesson. So all we need to do is substitute in for a and b. A is 8.75, so we'll have 8.75 squared plus 18 squared equals c squared. Here we're looking for the hypotenuse, the side across from the right angle. So using your calculator, you can take 8.75 and hit the x squared button, equals, and you're going to get 76.5625 plus 18 squared is one that you should know. Remember that we learned our squares, perfect squares, from 1 to 20, but if you don't know it, you can use your calculator and you should find that it's 324 equals c squared. And then we need to know 324 plus 76.5625 equals 400.5625 equals c squared. Now remember that when we solve these, we're going to take the square root plus or minus the square root of 400.5625, and that's going to get us c, because remember, when we take the square root of c squared, we get c. Now, if you know your perfect squares, you know that the square root of 400 is 20. So the square root of 400.5625 is going to be about 20. So approximately, or about, remember that we're going to, instead of using the equal sign, which says it's definitely that amount, we're going to use the approximately sign to show that it's not exactly 20, but it's close to 20. Now, if you aren't sure how to do that in your head, you can always take your calculator, hit the second x squared, and then put in 400.5625 equals, and you're going to get 20.01405756, and when you round that to the nearest tenth, you're going to get 20. So our answer would be approximately plus or minus 20, but we know that you can't have a negative length on a ladder, so we know that the ladder is approximately, or almost, or about 20 feet long. Let's say about instead of almost. So the ladder is about 20 feet long. Underneath this problem, we have a practice problem. It says write an equation that can be used to find the height of the plane, then solve, round to the nearest tenth. So let's take a look at it again. You'll notice that your figure over to the side doesn't have any information on it. So let's go ahead and fill in that information. Let's fill in 12 miles for the hypotenuse, or the side that is directly across from the right angle. Let's fill in 10 miles here, and then let's make this B miles. So we want to know the distance, the height of this plane. We're looking for the height of this plane. We know that the distance between them, or the hypotenuse, is 12 miles, and we know that this side is 10 miles. So I want you to take the information that you know, and let's fill it in. Let's just go ahead and work this one together. So we have a squared. We know that a is 10 because the hypotenuse is always c. So we have 10 squared plus b squared equals c squared, which is 12. So 12 squared. 10 squared is 100 plus b squared equals 12 squared is 144. Remember, if you don't know these, you can use your calculator, but these are ones that you should have already memorized, or that you need to memorize if you haven't. Now, we need to get b squared by itself. This is just solving an equation, and we have a positive 100, so we subtract 100 from both sides, and we get b squared equals 44. So we're going to have b equals plus or minus the square root of 44. If you use your calculator, I know that the square root of 36 is 6. I know that the square root of 49 is 7. So I know that it's going to come somewhere in between those two numbers. So second square root 44 equals plus or minus 6.633249581, but I want to round it to the nearest tenth, so 6.6 miles. Now we know it can't be negative, so the height of the plane is about 6.6 miles. All right, turn the page over to the back side, and there are two practice problems. I want you to take a few minutes and pause your video and try to work those problems out. And when you come back, I'm going to give you the answers to those problems. And if you don't get them correct, I would like for you to go back and see if you can figure out what you did wrong. And then we'll check them in class tomorrow to see if you actually worked those out. Okay, now that you've had time to work your two practice problems, let's look at the first one. It says Mr. Parsons wants to build a new banister for the staircase shown. If the rise of the stairs of a building is 5 feet, so the rise we know is up and down, so the rise is 5, and the run is 12. Remember that the run is going to be the horizontal, so 12. Then it wants to know what is the length of the new banister. So it's asking what is the length of this. Remember that this is the right angle. So we're actually looking for the hypotenuse because that's the one across from the right angle. And your answer is going to be C equals 13 feet. Now remember, I'm going to be looking to see that you actually completed the work, and I would like for you to correct it if you didn't get it right. Look at the next one. It says Anita is decorating for a party. She attached an 8-foot streamer to the top of a wall and to the floor 4 feet away from the wall. Assuming the wall is perpendicular to the ground, what is the approximate height of the wall? Draw a diagram to help you answer this question and then show your work. So this is the part I'm going to be looking for tomorrow, but the answer is going to be B, 7 feet. So make sure that you show your work, draw your diagram, and we'll take a look at it in class tomorrow. Now I know that your notes has another page. That's actually for the next section, so just hang on to that, and we'll use that when we start section 5-7.